All right, so we're going to do a video talking about our double angle identities and what they are and where they come from and how to use anything with them. So the other day we discussed doing our sum and difference identities, and that's where our double angle identities come from. So the sine identity, as it says right here, use the sum identity to show that sine to u is equal to 2 sine u cosine u. So in order to do that, we can take sine 2u and we can rewrite that as sine u plus u, because that's using our sum identity. Now, if you recall from the other day, our sum identity for sine is that if I have sine u plus v, that's equal to the sine of u times the cosine of v plus the cosine of u times the sine of v. So cosine u sine v, right? And so now instead of having v, we're just have both of them being u plus u. So really what we're getting at this point in time is it's going to be the same as having sine u cosine u plus cosine u times the sine of u. So you can see right here, if I have the exact same thing, sine u, cosine u, and then I'm adding cosine u, sine u, that's no different than if I did x times y plus y times x. If I have both of those, you could rewrite that as just that is equal to 2 times xy. Because order doesn't matter when you're multiplying. I just have x times y and y times x. So like I said, it's the same as having like 3 times 4 and 4 times 3. Those are the same. It doesn't matter. So if I'm multiplying here, just because this starts as sine and ends with cosine, and this one starts as cosine and ends with sine, they're the same exact thing though. So this is 2 sine u cosine u. And that's exactly what we needed to do. I'm showing that that sine 2u is equal to that right there. Okay. So that's how we get our double angle identity for sine. I can go through and do the exact same process for cosine. So if I do cosine 2u, we can rewrite that as cosine u plus u. And using my sum and difference identity for cosine, if you recall back, cosine goes cosine u cosine v minus sine u sine v, right? So instead, if I set this up, instead of having v, they're both u's. So it's cosine u cosine u minus sine u sine u. Now, if you notice right here, if I gave you something like, for example, if I said I had x times x minus y times y, you would go, oh, well, x times x is x squared, and y times y is y squared. Well, that's exactly what I have here. So this is cosine squared u minus sine squared u. And that's where we get our identity right here for cosine squared, right here. I shouldn't say cosine squared, but cosine 2u is cosine squared u minus sine squared u. Okay? Now, if you notice, cosine has 3 different ways of writing it, and that's just one way that I showed you. I can go ahead and get these other 2 ones right here just by using a Pythagorean identity and substituting in. We should know at this point in time that cosine squared, for example, is equal to 1 minus sine squared, right? These are equivalent statements. So instead of having cosine squared here, I could go ahead and replace that with 1 minus sine squared u, minus sine squared u, because I'm just bringing this part down. Well, if I had 1 minus x squared minus x squared, you'd have 1 minus 2x squared. So here I have 1 minus 2 sine squared u. And that's where I get this third equation right there. And I'm going to do the exact same thing to get the other one that I have right here, the 2 cosine squared minus 1. But instead of replacing cosine squared in this equation, I'm going to change my sine squared instead. So if I have cosine squared u minus sine squared u, I'm going to replace this sine squared with cosine. So we have, that's minus 1 minus cosine squared u. Now, notice right here, I put parentheses, or really I put brackets around this. The reason I put brackets right there is because if I'm subtracting sine squared, this whole thing, 1 minus cosine squared, is equal to sine squared. So if I'm subtracting it here, I have to be subtracting it here. So that means that I'm going to be taking this subtraction sign and distributing it to what's behind it. So this becomes cosine squared u minus 1, because I distribute the negative, and then I distribute it again, and that becomes plus cosine squared u. Now, once I've done that, I have cosine squared plus cosine squared, so that's 2 cosine squared u minus 1. And so if I come over here and look, sure enough, that's the second one that we have right here for cosine. I could go ahead and do tangent. It's just not necessary at this point in time. It's just going to be really ugly if you try to do it. Go ahead and try and do it using your sum and difference formulas if you'd like to. But just remember that you've got the tangent equation, so you end up with a fraction over a fraction doing that one. All right, so let's go ahead and actually apply this information here. All right, so here we go. We're going to go ahead and verify here. Now, it's important that we discuss that verify. It means that you're just showing that the left side is equal to the right side. We know it's equal to it. We just have to show how it's equal to it. So basically, you're proving it. Okay, so there's multiple ways to do each one of these. It's just sometimes one way is easier than the other. Think about it in terms of this is similar to simplifying. It's just I'm actually given the answer. I now know where to stop, and sometimes it's not always the simpler way. So just kind of keep that in mind as you're going through. I'm going to do this slightly differently than how I did it in class and see if maybe this might make a little bit more sense. And I'll also do it the way that I did it in class. So here, if I'm going to go ahead and do this, I'm going to make the right side equal the left side. So I'm going to change this. Now, if you notice, I have 2 sine 3x cosine 3x. So let's consider. If I instead had 2 sine u cosine u, we should know from our identities that we have right here that is equal to sine 2u. So that would be equal to sine 2u, correct? So instead, here I have 2 sine 3x cosine 3x. So what I'm going to do here is I'm going to say instead, I'm going to say this and this is equal to u right here. So instead, I'm going to have that 2 sine 3x cosine 3x, that's going to get me sine 2 times 3x, because that 3x right there is the u. And so then I have sine 6x, and that's going to go ahead and get me sine 2 times 3 is going to go ahead and get me 6x. Bam, done. Okay, it's pretty easy, right? But you have to be able to understand that I'm taking that whole entire 3x and I'm just putting it in there for that u. We're essentially saying, in this case right here, let u equal 3x, okay? Now I can do it another way, the way that I did it in class. So if I was to do it the way that I did it in class, I would have sine 6x, right? And I'm going to show that that equals the 2 sine 3x cosine 3x. So instead, I'm going to change the left instead of changing the right. So I'm going to change the left and make it look like the right. So at this point in time, if that's what I have sine 6x. So I can go ahead and I can split that up as sine 3x plus 3x, right? Just doing what we did in our opening part there, where I was just kind of showing you how we get the double angle identity using our sum identity. So because 3x plus 3x is equal to 6x. And so here on the left, I'm just going to go ahead and replace this right here with my sine formula, my sum formula. So that would be sine 3x times the cosine of 3x plus cosine 3x times the sine of 3x. And so I can see this right here and this right here. I have two of the exact same things. So just like we did to get our original one, I have 2 times sine 3x cosine 3x. Okay. And sure enough, that's equal to exactly what we needed it to equal to. Okay. Why did I write that as a 2x? Why did I do that? That's supposed to be a 3. You know, sometimes when your brain goes a little bit faster than your hands. Good times. Okay. All right, so there you go. It's all the left does equal the right. So let's go ahead and do number 2 right here. So this is sine 4x is equal to all of this crazy stuff over here. It's way easier for me to go ahead and take what I have here on the right and simplify it and make it somehow look like this. It usually works out that if you take the side that's more complicated looking, you can usually change it and simplify it to make like the easier side. It's more challenging to take something that's really easy and simple and complicate it, because that's basically what you would have to do. So you'd have to change that sine 4x a whole bunch of different ways to somehow make it look like that right side. So what I'm going to do, just bring down the sine 4x and say it's equal to, and now I'm going to change what I have over here. So let's look here at this 4 sine x cosine x. That's almost our identity that we have up here. It's 4 sine x times cosine x. Well, almost this first one of 2 sine x cosine x. The only difference is that it's just got 4 there instead of 2. So what I have instead is that's equivalent to 2 times 2 sine x cosine x. Do we agree? Because if I distribute that 2 right there, it equals the 4 sine x cosine x, right? Okay, so that's changing one thing. And if I have the 2 cosine squared minus 1, what's that? Well, if I come over here, 2 cosine squared minus 1 is going to equal cosine 2u. So that's what I'm going to have here. So I'm going to change that to cosine 2u. Oh, not u, sorry. Should be x. Okay, so that's what we've got there. Okay, we're getting somewhere. Now we just kind of need to change some things around. So if I have sine 4x here on the left still, I still have the 2 right here because I'm just bringing that down, but I can change that. That is my sine 2x. Okay, I don't even need the parentheses. I get a little parentheses excited sometimes. Okay, and that's cosine 2x. Sine 2x cosine 2x. So that's very similar to my equation that I have for sine 2x. So if you recall, if I have sine 2x, that's equal to 2 times sine x cosine x, right? Well, the only difference here is that this value right here has a 2 in between the cosine and the sine, between the x's right there, okay? So now I've got to somehow figure out how I can make that happen here. Well, if you notice right here, what I've actually got to make this equal isn't sine 2x. I've got to make that equal sine 4x. So if you think about it this way, I've got sine 4x is equal to 2 times, and I'm just going to drop the parentheses. Okay, all I did was drop the parentheses, changed nothing else. So now what I can do what I did earlier and say that, let's say let u equal 2x. And so here, if this was a u, that's what I'm going to do. So if I have 2 sine u cosine u, that would equal sine 2u, correct? And now I'm just going to go ahead and put that 2x back in. So instead of it being u, I'm just going to replace the u with the 2x. So here it's 2x, here's a 2x, and now here's a 2x. So that's what I could do right here by using this formula that we have up here for sine 2u, right? And what I'm trying to do is I'm trying to show that this is in fact equal to what I've got right here is sine 4x. This part right here is just this equation. It's my double angle formula for sine 2x. That's all I did was just put the whole thing there, okay? So now if I just bring down this left side, sine 4x is equal to, and I'm going to simplify this. I'm not worried about this right here because that was just me taking the whole equation and changing it and showing you how it substitutes in. So I'm going to change this part to that because they are equal statements, correct? Because 2 sine u cosine u is equal to sine 2u. So now I've replaced u with 2x, and so that means here, instead of it being sine 2u, it's sine 2 times 2x. Well, if I have sine 2 times 2x, what is 2 times 2? It's 4. So I have sine 4x is equal to sine 4x. Done, verified. So before I go on to solving, because this is just verifying, I will go ahead and do those in a separate video. So hopefully this was helpful.